This video is about performance tuning database queries. I do the demos in Microsoft Access, but all the basic rules I'm going to show here are applicable to basically any database management system. If you're new to database development or to Microsoft Access, then you absolutely must watch this video. If you're an experienced Access developer, probably you should watch it too. Hi, I'm Philip from codekabinett.com, and as I said, today I'm going to talk about performance tuning queries. And these techniques here are really applicable basically universally. Usually if you talk about performance tuning one particular query, the answer is often, oh, it depends on this and that, and it's hard to find general rules. But I think the rules that I kind of compiled in this video today are really universally applicable. So you can just keep them as a checklist and memorize them. So, well, I assume basically your database is normalized and all the fields that you're using criteria on in Access queries are indexed. That are basically givens that I assume here. If you're not sure about indexing, how it works, what it does, then look at this video that I'm going to link there. And there I talk in detail about indexes. Today I'm going to show you a couple of queries and how they can be optimized, and that are very common scenarios that you will encounter basically on a day-to-day basis. Okay, let's dive, no, not yet. Before we get started, I need to explain my setup here, because it was really difficult to get a good scenario to show you the effects of the changes I make to the queries. And now I've got the Northwind database filled with a lot of data, like 100,000 customers and 1.5 million orders, and that will be the tables we're working on here primarily. And it's sitting on my local computer on a fast SSD disk. So the query differences will be in seconds or fractions of seconds even. But you need to keep in mind, if you have a database in a real production scenario sitting on a file server that you connect to via a network, then these differences will multiply. They will become really noticeable even without kind of a stopwatch measuring the execution time. The reason why I didn't use the network scenario is because it's very unpredictable in some regards, because the file caching over the network and server usage and stuff can have a huge difference, and it would have happened that I say, yeah, this is a very bad example because it takes like 5 seconds to execute, and then I would run a different query and say this is much better, and then I execute it and it takes longer than the bad one because like data was dropped from some cache and needs to be reread over the network from the disk, or there's other factors influencing that. So a basic scenario that kind of reproducibly shows all the effects, but they are very small. Always keep in mind they will be much bigger in a real world scenario. Okay, and now let's get started. Okay, this is the Northwind database, and I added a small query form that does, hang on a second, I'll fetch the first query here and then I'll show you the special stuff about my tool. Whenever I execute a query, the background will flash in green, so you will also notice it when the query is executed, because the result window might not really change. These are the results if we have multiple queries in here. then the active results that really belong to the query you see above will have the green lines in there, while the other query here that is belonging to here, which now becomes green if I switch between different queries. So, and the most important thing here is this one. I time the execution of the query, and the first one is in seconds. That's just done with a date diff, and it's not very accurate. It would have been helpful if I had used the network scenario where it would take like 5 to 10 seconds to execute a query. But here in this scenario, we need to totally focus on ticks that are basically milliseconds, measured in like a 10 millisecond or 30 millisecond precision here. And that is what we need to focus on. Okay, now this one is the first query that's common. You use a like operator to find this term anywhere in the last name of a customer. And that executes pretty quickly, like 600 ticks, a bit more than half a second, but we can make this quite a bit faster if we remove the first star and run this one. And now you see it basically halved execution time. So whenever it's possible to search starting with the beginning of the data, then do that. Of course, you need to weigh user experience here, because maybe the user wants to search anywhere inside the last name, and then you can't drop the first star to start only search only with the start of the term. But if you can, you should absolutely do it, because this way an index can be used, and there is of course an index on last name, while with the start, the beginning, that can't happen. And if we make this for equality, a check for equality, that doesn't really do much, because the important part is that the index is used, and just checking for equality doesn't improve things here. So I quickly close that and get rid of the results, and we look at the next example here. We want to see all the shippers, all the orders that are in our database system, except those that are sent via the shipper with the ID number 6. So this takes about 2.5 seconds to execute. And to improve that, we need to take a quick look at the shippers table here. So we have 6 records in here, and we want to exclude the one with the ID 6. And that is basically why we use that query here. But as we have seen, we could also write the query with less than 6. And now let's execute this. And just before 2.5 milliseconds, and now we are down to less than a second. So it's 3-4 times as fast basically here. But it's not always really feasible to check for less than a value or greater than. What we could also do here is use the in operator, and we just saw, I messed things up here. I just switched my keyboard to US, and that drives me crazy. So let's hopefully quickly fix that. Oh no, I had that turned on. So okay, where were we? We can also use explicit values in here, like 1, 2, 3, 5, and that would also limit down the number of records, as in the previous query with greater and less than 6, to eliminate that. And that is not as fast as the less than operator, but still much faster than the original query, which took more than twice that long. So once again, here the index can be used, while with the other unequal operator it can't. So let's move over to another variation of this, because it's not really sensible to use hard-coded values in your queries unless it's an ad hoc thing. But inside an application you would rather use some query to get to the shipper you want. And what I did here in the shippers table, this is the number 6 shipper, and I added a new column here that's not in the Northwind by default. General parcel service, and all shippers have that checked except for the one that I want to exclude with the ID 6. So now we run this query here. And you see it's taking longer. That is basically the equivalent to our is not equal to 6 that we had at the beginning. So it takes about 7 seconds to execute that. And we can do the same as we did with our value list. We kind of invert that and say we want to query for the shipper ID in those records we actually want. And now we run this, and it should come back quite a bit quicker. So 2.5 seconds basically. And that is more than twice as fast here. But it's still quite a bit slower than the hard-coded values. I'm not really sure why that is, but we just accept it and look at another variation of that query. We can also write a different type of subquery and put it in a new window in here with where exists, and it's basically going to the shippers table as we did before and only fetches those shippers we want to show data for. Now we execute this, and I don't expect too much difference here. It's actually a tiny bit slower than that, but I think if we execute it again, maybe it will be like a tiny bit faster. Doesn't really make much of a difference here. That's slightly slower. So tiny difference. But what will make a difference is if we use a join to get another table in here. So here we join the shippers table to our orders table on the shipper ID, and then we use the general parcel service field as a criteria in the main query. Now let's run this one. So not too fast actually. I expected it to be faster, but it is a little bit faster than the SubQuery variations, but not too much. But that's still something you should keep in mind. Generally, in Microsoft Access, a join to get criteria or data from another table will almost always be faster than a subquery. There might be a few exceptions, but I think in 90% of the cases, or even 95% of the cases, the join will always be faster. And I'm really surprised that the difference isn't bigger than this, but well, we just have to accept it here. I don't know what's causing it, but usually it was quite a more significant difference. But anyway, well, one thing I'm asked about often is functions in queries, and I just clear the stuff here away so we have a clean slate to start with. So here we use a function in the query, formatted address, and let's quickly look at that function. It's taking the country, the state, postal code, city, and all the stuff, and then it formats the data like for an address label or something, using the appropriate format that the postal service in that country will expect. And it's just concatenating the strings, but it's using slightly different sequence of fields and maybe slightly different formatting. We don't need to look into that. And I use that in the where condition to format the address, and then I use a like condition to filter on that data, to filter for postal code and city. That is actually in Germany, so this is correct and will yield results. And you also see it's once again using the like operator, which is also quite bad. So we run this, and it took like 2.5 seconds. And let's do something. Let's put in the result of that here and run it again, because I want to show something, that it's not the like thing here. I try this. I haven't planned for that. Let's replace that with an equal operator and do it that way. So that should also match. And we're not using the like. I told you earlier about that it is bad. So run this, and it produces the correct result. And the execution time has slightly improved, but it's still not very good here. So now use a different query where I use the individual values for the postal code and the city, and I want to cut this and put this in here. So run this, and now you see the results are here, and it takes only a fraction, like a quarter or a fifth of the execution time. So this seems to confirm the myth. Functions inside queries are bad because they kill performance, and your queries will become slow whenever you use a VBA function inside your query, and you should never do that. But that's not true. It's only part of the truth. You should not use a function on database, on table fields in the where condition. If I now go back and put in my function call up here, and run this query, and look, it's like 300 milliseconds, and we run it again, and it became even faster, but that is by chance. I wouldn't expect any difference in execution time, or not a really measurable difference, because now only the 3 records that are found need to be processed by the function, and the database engine can still go to the table and use the indexes to fetch the data, and only get back 3 of the 100,000 customers, and only for the 3 the function is invoked, and then it doesn't make a difference. So if you use functions in the output columns of your query, they will not do much harm, at least. It depends, of course, on the function. If your function takes 1 second to process some data, then it will slow down your query. But if it's something simple that finishes in milliseconds, then it doesn't really harm query performance if you use the function in there, even if it's a VBA function. Now, while we are with the functions, that also applies to built-in functions like these here, year and month. And I basically used that to query orders that were entered in the current month. And let's run it. And it takes like 2.5 seconds to complete. And once again, the function call on the database field kills off the index usage and so makes the query much slower. If we instead use this query, let's use a new one here. If we use that with hard-coded date values here, but just to go back, the criteria was hard-coded here as well, so we don't lose much here. But we just run this query, and it is much faster with less than half a second execution time. So what does it mean? Usually you don't want to use hard-coded values. Of course, if the user enters them, then you can build the query string with these hard-coded values that you kind of insert into the query string, though everything's fine. But sometimes you have queries where you say, yeah, this query should dynamically show the orders of the current month without the user entering anything there. And then you can also use functions, but the important part here is you must not use the function on the table field, but you need the function to process your criteria. So here we fetch the date, the current date, and extract the year. We fetch the date again and extract the month, and then we use the one for the first day in the month. And the same happens here, but we just add 1 month to the date. So this is basically the same query as before, and it's still blazingly fast, executing in less than half a second. And there's no problem with using a function here, because it's only processed once on the input criteria and not for each row in your table. So sometimes you are in the unfortunate situation that you absolutely have to use a function on the table values. An example is this one. So we have a very simple query here. We run this. It's blazingly fast with like 300 milliseconds, but there is a problem with it. We really want only to show it records that match the case with a capital M in the Mad Max company name. And you see, this would be a correct match, but this should not be in the query. But it is, because Microsoft Access always uses case insensitive comparison in query criteria. So how can we fix this? We can use the string comparison function like we do here. And this will do a binary compare of the string, and then it will of course be case sensitive. But we have to apply that to our database column. So we have to do it basically the wrong way, but there is no other way, at least not obviously. It is still pretty fast with executing in half a second, but we can make it faster. And that is a technique you should remember when you encounter the situation that you need to use a function to get the correct results. We can add another condition here that also queries the company name for our criteria. And as we have seen before, that kind of gives us the correct results, but with incorrect capitalization here. But now let's run this query here. And these are the results, and they are correct. And the execution time is once again down to less than 300 milliseconds. So, because now the database engine uses the normal case insensitive search to narrow down the records to just the 2 that remain there, and only the 2 are pushed through that function, and that doesn't take much time, so the query is still extremely fast here. So, one more thing. I've got one more thing here. That's an exception to all the other examples, because it will, let's see, we'll show. So, this is nothing special, it's just querying for the name. And I got in a bit of a dispute once in a forum because someone used the bang operator in an access query, and he had problems with that query. And I said, yeah, the bang operator is wrong. You need to remove it. And that, I was told, is incorrect, and it's indeed incorrect, because you can also use the bang operator to separate a table name from the field name. And I accepted that it works, but I was kind of totally convinced that it must force the database engine to evaluate that term like an expression and do basically what we have seen with the functions, and it would kill performance, and I thought it will not be a good idea to use that because it will create problems, but actually it doesn't. So the AccessJet database engine is able to really process that in an effective way, and it does not affect performance if you use the dot or the bang operator in Access. Nevertheless, please still do use only the dot to separate table name and column name in SQL queries, because it's only Microsoft Access that understands the bang operator in for that purpose, and no other database system will understand that. So you should really get into the habit not using the bang there. But performance-wise, it doesn't make any difference. And I was quite surprised about that, but I never had the real kind of definitely reproducible scenario to kind of verify that. So, yes, we are almost at the end of this video, but I would like to tell a small story. When I was a very junior database developer and basically working with my very first client as a freelancer, I got the client. They had an Access database and they wanted me to build it with a SQL Server backend, and they gave me the database. And they said, yeah, that this needs to be converted to SQL Server, and also we need to query another database that wasn't implemented yet. They were kind of looking at the other application with that database in the backend and typing the stuff from the screen. And of course, they want to streamline the process, and the application should also query the other database and update some local data with the values from the remote other SQL Server database. And the Access database contained like 1,000 records or so, and I had that, but I couldn't get the other database because there was lots of confidential data in there, and the client couldn't get me any access to that. But they said, here is the structure of the database. You can work against that to build the queries for that. And so I thought, yeah, well, I knew there's more data in the other database than in my local Access project I'm working on. So I've got 1,000 records locally, like we add 2,000 fake records to my development version of that other database. And then I worked happily away and completed the project, delivered it to the client, and then they put it into production. And the next day, the project manager at the client called and said, yeah, well, your application does not work. I said, why? Why is that? And they said, yeah, whenever we try to update the data from the remote database, the application stops to work. It basically freezes and doesn't do anything. I said, oh, that is weird. And the project manager said, yeah, I asked our database administrator about that, and he thinks that could be a performance problem and you should talk to them directly. I said, oh, I don't think so, but I'm happy to talk to them. So I rang that database administrator, and he said straight away, yeah, I think you've got a performance problem in your application, and that is probably because the database you are hitting there, that is a big database. And I should have kept my mouth shut, but I was inexperienced and I didn't. I said, no, that can't be the case. I'm experienced in working with big databases. I had databases that were 1 gigabyte or 2 gigabytes in size, or I even had one some time ago that was 10 gigabytes in size. I can handle big databases. That should not be the cause of the problem. Yeah, and the DBA then replied, oh, I would never use the term big database for any database that is less than 100 gigabytes. And the one we're dealing with here is approaching a terabyte. Yeah, and then I was shut down a little bit and said, yeah, oh well, okay, then let's talk about performance tuning. And yeah, we worked out a couple of solutions, improvements to my queries, and then they run pretty fast, that there was no complaint, and the application worked, and the project was a success. So it all turned out fine in the end. But the lesson from this is, whenever you build a database for a client, performance-wise, the most important question you need to ask right from the start is basically, what kind of data volume do you expect? How many data is probably going to be in that database, and how much is added over the next year or next 10 years? And then you should kind of get the amount of data that the client told you that is to be expected in that database, and you should get that into your development database for performance testing. Of course, you can't do that if they say, yeah, we are going to add a terabyte every day to that data. Then you can't do it. And that is not really what I'm telling you here. But you mustn't use tiny development databases, because everything will be fast in a development database. If it's sitting on your local computer, you're the only person working with it, it will always be fast, even if you add a lot of records. So if the client tells you there will be 1 million records in certain tables at the end of the year, you should add the 1 million records and test against them. And if you get good performance out of that, then it probably will not be a huge problem if they add another 1 million records the next year and another 1 million the year after. It still should all work as best as it is, but you need to have a decent volume of data to start your performance testing. Otherwise, you can't really measure if your queries are performing at all. So I think, yeah, that is basically it. Thank you very much for watching, and I'll see you next time. Thank you.